Alright, so now we can move on to section 4.2, which is a really neat tool called linear approximation. And basically what this is it's using the slope and the equation of a tangent line to approximate things that might be a little hard. So for example, let me just jump right in. Let's say I wanted to estimate the square root of, let's say, 9.1. Okay. So doing this by hand is a little hard because it's 9.01, which isn't really a perfect square, so it's not really easy to do this by hand, right? But something that I do know is the square root of the 9. So I can actually use that to get really close to what I actually want, okay? So what I can do is let's let f of x be equal to the square root of x, okay? And what I can do is I can use the equation of the tangent line at x equal to 9, since I know that one, and I can get really close, okay? So remember to do the tangent line, what I need is a point and I need slope. Well, if I want it at x equal to 9, then for the point, just plug in 9. Square root of 9, which is equal to 3. So my point, x equals 9, y is equal to 3. So I know that point. To get our slope, I just need f prime of x. The derivative of the square root of x, we have seen this a lot of times, is 1 over 2 square roots of x. I can do that by having this written as x to the 1/2, and then use the power rule, bring the 1/2 down, x to the power of, subtract a 1 right here, so it would be negative 1/2. The minus sign means I can bring it down, so 1 over 2 x to the 1/2. Well, x to the 1/2 is the square root of x. So that's where we get that from. So plugging in our point, my slope is the derivative at 9, so 1 over 2 square roots of 9. Square root of 9 is equal to 3, so 1 over 2 times 3, 1 over 6. So I have a point, and we have our slope, and so I can put this into point slope form now. Remember, point slope form is y minus the y that I know, so y minus 3 is equal to our slope times x minus that x, minus 9. Solve this. X minus 9 over 6 is like saying 3 over 2. Add 3 on both sides. Y is equal to 1/6 x. Negative 3/2 plus 3. That's like doing 3 minus 3 over 2. So that would give you 3 over 2. So plus 3 over 2. So I know at x equals to 9, the square root is almost the same thing as 1/6 x plus 3/2. So if I want to do the square root of 9.1, that's about what I get when I plug 9.1 into this. And if I were to work that out, 1 over 6 times 9.1 plus 3 over 2, you get about 3.016666666. Repeating 6. So again, this is just a helpful way to get really close. Find the equation of the tangent line whenever I'm really close to what I want right here, and then plug in the point that I actually want. So like here, I knew these square root of 9, so I found the tangent line at x equals to 9, which is what I did all right here, and then just plugged in 9.1. Let's do that same thing now. Example. Let's estimate the cube root of 7.9. Cube root of 7.9. So this is really close to 8. And I know what the cube root is for 8. So why don't we let f of x be equal to the cube root of x, because that's what I'm trying to do, right? And let's find the tangent line at x equals 8, because it's really close. Okay. So to find a point, just plug in 8. The cube root of 8 is equal to 2, so I have the point x equals 8, y equals 2. Now I need my slope, so I need f prime of x. Cube root of x is like saying x to the 1/3. So when I take the derivative of that, excuse me, so sorry about that random noise. When I find the derivative of that, bring our 1/3 down. X to the power of minus 1 gives you negative 2/3. So you can leave that, or you could rewrite that as 1/3 x to the 2/3. It doesn't matter. But basically it's 1/3 times x to the 2/3. Plugging in an 8. 1/3 times 8 to the 2/3. Whenever I do 8 to the 2/3, that's the cube root squared. The cube root of 8 is 2. 2 squared is 4. 4 times 3 is 12. So my slope is 1/12. So putting this in point slope form, y minus 2 equals 1/12 times x minus 8. Solving this for the y, you get y minus 2 equals 1/12x. 8/12 is like saying 3/4. Add 2 and you get y equals 1/12x. 2 minus 3/4 is like doing 5/4. Yes, so plus 5/4. So the tangent line of the cube root of x at x equals to 8 is y equals 1/12x plus 5/4. So if I want to find the cube root of 7.9, that's about, I can just plug this in to that guy here. 1/12 times 7.9 plus 5/4. And if you were to work that out, what you would get is 1.90833333, so 3 repeating. Again, what this does is it helps us get really close to a value that normally I can't do. All right, another example. Let us estimate the sine of 62 degrees. So first things first, when we reviewed trig at the beginning of this class, we said we always want this stuff in terms of radians, okay? This is obviously not. So to turn that back into radians, remember we multiply by pi/180. If we reduce 62 over 180, what we get is 31/90. So that's 31 pi/90. So that's really what I want, okay? So let's think about this. What is close to 62 that I know? Well, I know what sine of 60 is, so why don't I use that then, okay? Sine of 60, if we look at the unit circle, sine of 60, sine is the y, so it's the square root of 3/2. So I know I have the point. Remember, I want to turn it into radians, so pi/3. So we have the point pi/3, square root of 3/2. To find the slope, I need the derivative. If I'm using sine of x, then the derivative is cosine of x. So our slope is equal to the derivative at this point, pi/3. So cosine of pi/3, which is, if I look at pi/3, cosine is the x, so 1/2. So my slope is 1/2. So for this one, I would do y minus the y that I know, which is square root of 3 over 2, equals our slope, which is 1/2, times x minus the x, which we know is pi over 3. Solving this for y minus square root of 3 over 2 equals 1/2 x. 1/2 times pi over 3 is pi over 6. So minus pi over 6. And then just add square root of 3 over 2. We don't have to combine these because one has a pi and one has a square root, so we can just leave it. Y equals 1/2 x minus pi over 6 plus square root of 3 over 2. So if I wanted to estimate the sine of, remember we turned it to 31 pi over 90, all we've got to do is plug that into this guy right here instead. So 1/2 times 31 pi over 90 minus pi over 6 plus square root of 3 over 2. 1/2 times 31 pi over 90 is 31 pi over 180 minus pi over 6 plus the square root of 3 over 2. You can get a common denominator, so we could do 31 pi over 180. To get to 180, I would need to multiply by 30. And then to get to 180 here, I need to multiply that by 90. 31 pi minus 30 pi is 1 pi, so we get pi plus 90 square root of 3 over 180 is about right. One more example of linear approximation. Let us estimate 1.01 to the third. So again, a function here that I know is x to the third, and I can do that if x is equal to 1. So let's find the tangent line at x equals to 1. So first thing I need is a point, so plug in 1, that's 1 cubed, 1 cubed is 1. So I have the point 1, 1. And then now I need my slope. I need to find the derivative first, bring the 3 down, which would make it 3x squared. So my slope is the derivative at my point, so x equals 1. So 3 times 1 squared. 1 squared is 1. 1 times 3 is 3. So now I just do y minus the y that I know equals my slope times x minus that x. Solve this for y. Y minus 1 equals 3x minus 3. Add 1. Y equals 3x minus 2. So that is the tangent line at this point. And so now I know that 1.01 cubed is about 3 times 1.01 minus 2. 3 times 1.01 is 3.03. And then when I subtract 2 from that, you get 1.03. So it's about 1.03. So whenever you hear linear approximation, what it really means is I want you to find the equation of the tangent line. And then if I want to approximate this, just plug in